The next thing is differentiability. Differentiability is looking for, is the slopes of those tangent lines, if we look at all the tangent lines that are going on, are those slopes kind of like meeting together? Are we getting basically the same nice limit stuff that we were getting before? We don't want one of them to be kind of coming in like this and then the other tangent line trying to like meet up with each other. We don't like that. We want things to be smooth and for them to work out nicely. So we want the slope of the tangent line, because remember, derivative is the slope of the tangent line, a slope of the tangent line on one side to be the same as the slope of the tangent line on the other side, and they should be the same in the middle. It shouldn't, like, once you kind of reach that middle point, it freaks out and does something else. Where this can show up as not quite working, so that's the same thing. Where it can show up as not quite working is where we've got a horizontal line trying to meet up with another horizontal line. This has got a nice slope. We can make tangent lines there. It's great. This has got a nice slope. We can make tangent lines there, but this one's kind of heading towards a negative number. This one's heading towards a positive number, so that's discontinuous, and it's not differentiable at that discontinuity. We also don't like it when it's sharp. We don't like sharp points. So when we're coming in on one direction, we're coming in with a negative slope. When we're coming in from the other direction, we're coming in with a positive slope, and then suddenly it's like, okay, well, what is our slope anymore? We don't get anything quite so nice. You can see that if we went back to here. Boop. So I'm going to keep our nice tangent line. So right here, it's like we're getting our same slope. It's not really doing anything. And then suddenly, it freaks out. It doesn't even show up there at 0, but it's like freaking out at that point. We don't really like that. What we much prefer is this. As we move along, see how it's just kind of naturally flowing across that line? That's what we want to see the slopes doing of our tangent lines. They should be a nice kind of like, ooh, look at how nice and smooth that moves around. That's what we're looking for. We also don't like cusp points for the same reason we don't like these. So we're kind of curving in. So we're curving in all right, but then it's like, okay, well, which one do we listen to as we're checking that limit? Finally, we don't like vertical tangent lines. So this would be like the cubed root of x. When it suddenly becomes perpendicular, we run into problems because the tangent line has to bounce from one side of our line onto another side of our line. Let's take a look at what that looks like. So I would like x to the 1/3. So as we check our tangent line, we're down here, and then as it comes up, it's underneath our graph, but then right here at 0, it doesn't really know where it should be, and then afterwards, it's on top of it suddenly. It can't really flow nicely when it reaches that vertical point because it has to go kind of from underneath our graph to on top of our graph. We kind of run into trouble there. We don't want to be running into trouble. So those are our 4 locations of non-differentiability. So if I was looking at these and I was trying to determine what kind of differentiability problems there are, the best thing you can do is to just take a look at its graph. So we were just doing this. This is a cubed root function. So this is that last type of discontinuity. We're just looking at it. It is a vertical tangent line. Okay. This other one, it seems like we got like cubed root and square root. Ooh, that's like 2 of those things. We know absolute value is going to be a sharp point. I know cubed root is going to be a vertical tangent line. How are the 2 of those going to mix together? How am I supposed to know? You put in your graphing calculator and see what your graphing calculator has to say about it. So there's our cubed root. Other side. Absolute value, please. Ooh, so that's doing that same cusp thing. So as it's going along, it freaks out at this point, even because it's getting almost a vertical tangent line, but it's also very sharp down there. And we don't really like that. That is not a good limit. So this is a cusp. Discontinuity. If you want, you can take a look at those graphs right there. Okay, finally, we have a graph here, and we would like to graph this function's derivative. So we don't even really know exactly what this function is, but we want to just graph its derivative. What's nice is it's in nice horizontal segments. So we know what the slope is at that point. Our slope isn't really changing all that much. In this section, that first section, it has got a slope of 1/2 of 2. We're going up 1 over 2. So up 1 over 2. Up 1 over 2. So we have a slope of 2, 1/2 all the way across that line. Since we have a slope of 1/2 all the way across the line, we're at a horizontal line right there at 1/2 because it's staying 1/2 the whole time. If we were taking a look at our slope right here, we are going down 4 and over 1. So we have a slope of -4. Down here at -4, we would put a little horizontal line because the whole way across it, it just has a slope of -4. In this section, we've got just a horizontal line. So that horizontal line has a slope of 0. The derivative is just the slope of the line at that point. What is the slope of the line at this whole time? It's just 0 the whole time. So we just have a 0 right there. Finally, we've got our slope here. It looks like it's going up 2 over 1, up 2 over 1. So we've got a slope of 2. It's got slope of 2 the whole time. So in this whole chunk right here, those 4 pieces combined together, those 4 colored pieces, is the slope of our tangent line. Is the slope of the tangent line at all those points, and it represents the graph of f prime of x. All right, now what values is the function not differentiable? So this has got a bunch of those discontinuities. So there's a bunch of places where it is not continuous. So it's breaking up. We've got a spot right here at 0. Oh, we got problems right there. So it's discontinuous at x equals 0. It's discontinuous at x equals 1 because it's jumping from the green chunk to the purple chunk. And it's discontinuous at x equals 4 because that's a jump from the purple chunk to the orange chunk. You could also say that the function is differentiable. So f prime of x is differentiable. If you wanted to say this in reverse. On the interval, let's see, we got -4 to 0, union, 0 to 1, union, 1 to 4, union, and then 4 to 6. Close. We aren't quite talking about endpoints right now, but right now we're just saying those endpoints. No good. I think that is it. Yep. So that is it for today. So here's our TLDR version of all the things that we talked about. So the slope of the secant line is without that limit. Once you tack on that limit, now you're looking at the derivative of that function. We were looking for our differentiability to be a nice curve because it should be moving evenly from one slope to the other and not like freak out at any particular points. These are the places that it freaks out. Biggest thing is the derivative is the slope of the tangent line at a single point. So we're trying to find slope using a single point rather than 2 points that you've been finding slopes in the past. All right. Sorry if this is a bit longer video. Sorry for all the cuts. It was a bit of a mess. You all have a good day. Thanks for watching.